Okay, welcome to another coding session. Continuing with Bangalang, our low-level explicit procedural compiled language that runs on the CPU and the GPU. I thought I might switch gears a little bit because I think we've been doing a lot of feature stuff recently and move more into cleanup. I guess we did a bit of cleanup in the last video also, but I think like this is where the bulk of the points that I have is within this kind of cleanup category. And I think it'd be nice to get some of this done so the language feels a bit more robust. And this one here is the one that I've decided to pick right now. And what is this? I'm saying nullify for empty compound literals. And then in brackets I say single nullifier per group of uninitialized members. So I guess a good way to explain this is with an example. So maybe I'll go into our playground and I might just comment out everything. Don't think we even need any imports. Just so that the assembly that we output is like just this. So if I say, I've got a big struct, which is a struct, and it's got some members, A, B, C, D, and E, and I'm going to initialize that, but I'm only going to initialize member C, so C equals 42. Yeah. So we have 5 members to initialize. Only one of them is getting a value, so everything else should have a 0 because that's our default in this language is 0 initialization. So this should be 0, 0, 42, 0, 0. So if I run that, okay, looks like it ran properly. And we have a look at the assembly for the playground. It's basically this assignment statement, right? And then we have an exit, and then everything else is just kind of like, it would be nice to clean this up actually, because this stuff we don't use any of this. We don't use this. We don't need these panics either. For this program, so it shouldn't really be in there. It should just be this assignment, and this is the exit, so this is exiting the program. Anyway, so how has it, what's the output in the assembly for this? Well, first we do 2 allocations actually, which is also an inefficiency, but we're not tackling that right now. The reason it does these 2 allocations, 5 bytes each, is because one is for the left-hand side, this variable here, and the other one is just like a temporary allocation to hold this. And the reason I have that is because, this is an expression, so it doesn't really work for structs, but, it could be like 4 plus 2 or something, so we allocate these, and it's not efficient, but anyway, we have a temporary allocation for this. That's why there are 2 allocations here. And then this is the part that I'm interested in. This is the initialization part here. So you can see the first byte at the start of the object of the struct, we're setting to 0. Then we go to the second byte and we set it to 0. Then the third byte, we put 42 in. Great. Then the fourth byte we set to 0. Then the fifth byte we set to 0. So what's wrong with this? Well, it would be nice actually, I think, if we could get rid of this and then just say 2, I want 2 bytes set to 0. And the same up here. I want 2 bytes set to 0. So there's the first 2 bytes set to 0, 42 in the middle, another 2 bytes set to 0. I feel like that's a little more optimal, especially if you get to bigger structs, you know, and you're just setting one value or something. It just seems just a little bit unnecessary. Or you know, what if I did this? If I didn't initialize it at all, I think, oh no, it's smart then. It's smart. Now I'm getting curious. What about this? If I say empty, so I'm assigning it a compound literal, but just with no values in it. Okay, this is where we get the, see, now we're doing like 5 times. This is effectively like a little loop, you know, setting each byte to 0, but it only does it 1 time. So this could be just one of these, you know, so that does it 5 times. So anyway, that's kind of my explanation. So let's see if we can tighten that up. I believe we can. I don't think it should be too tricky. So we want to go into our source. Should be generation for x86-64. And we're talking about compound literal. So there's like 2 kinds of compound literal. So if the compound literal has children, and we're not talking about assignments, then we go in here. So a compound literal that's not assignments, is like a, you know, like a slice. So I could say a slice of U8s, and then I could say like 1, 2, 3, right? So this is a compound literal. It doesn't contain assignments, like this is an assignment. It just contains values, or expressions, technically. So that's this here, you know, it's for arrays and slices only, I'm pretty sure. Yeah. And then we come down here. So this else is for these kinds of compound literals that contain assignments. So for a slice, you know, we have raw and length, and we deal with those. And this is what we're interested in. So for structs, we come through, and for each member in the struct, so this is the type. So these are the member type nodes. So for each member in the type, so that's these 5 members, we loop through, and we look for an assignment in our compound literal. So we look for a matching. So for A, we would look and we would see, no, it's not in here. B, no, it's not in here. C, yes, it is in here. That's what this loop is doing. If it does find it, it does a copy. You know, it copies this value into the struct. Makes sense. And if it loops through our compound literal and it can't find an assignment, then it does this nullify. This is what we saw before, which is setting the byte to 0. Okay. And because we have it within this loop and it's just like per assignment, that's why we get lots of them. So I think what we're going to have to do is store like a outside of this member loop. Yeah, outside the member loop, we're going to have to store like a nullify location and nullify size, I guess. Or nullify count. Something like that. So then when every time we come across like a situation when we say, okay, the assignment wasn't found, then instead of immediately doing this, we are instead going to say like, okay, if our nullify location has not been set yet, and the way we know that is because the type is none, then we set it to the member location. And we also want to get our nullifier count, and we want to add the byte size of the current member to it. Oh, spelled that wrong. And then I guess we want to just like do an else. So if we haven't found an assignment, then we make this bigger. And if we come to a case where we do find an assignment, so in the case we go here, didn't find it, so we set this and we add the size. Then we come here, still didn't find it. This is already set, so we don't worry about that, but then we increase the size of the area that we're going to set to nil. And then we come to here and it's like, oh, we found that. So before we set this 42, let's set all this to nil. That's where we are now. So if, I guess if nullifier count is greater than 0, or do we even need to, yeah, because this doesn't do an internal check. So if we found an assignment, but there's some stuff to nullify, then let's nullify it. Now we need to put a count in here instead of a type. So let's put a count like that. And we're going to need to check anywhere else that we use this. And basically just do the byte size. I changed it to 2 byte size, didn't I? 2 byte size? Yeah, there we go. And here's another one. So 2 byte size, like so. So those ones should be working now. And this one should be working. And now that we've done that, we want to reset our nullify information so that, you know, so we do this, we set nullify. But, oh, interesting, because it's going to do this first, I guess. And then it's going to do this nullify. It's still correct because it's still nullifying the right place. It's just a little bit confusing. I think for me, I would like the assembly to be kind of in order of the members. It doesn't matter. Like this nullify could be right at the bottom, even though it's the first member, and it would still work fine. It would just be a little less intuitive. So maybe we can take this out and instead put it here. So this is where, you know, we got to C, and then we looked for an assignment and we found one. We found the assignment for C. So then before we do the copy of C, we check, like, is there any nullifying we need to do? If so, let's do it. Okay, and this is the end of the for loop here, because then we also need to do it if we get down to the bottom and there's still, we don't need to reset stuff. But if there's something to nullify at the end, which would be the case for this, these two at the end need to be nullified, then we do that too. And I think that's about it. And I've just realized that I haven't set my timer. I haven't been doing many of these videos recently. I know I've been uploading them, but I haven't actually been recording them recently. So let me start a timer, and I'm just gonna have a look here. 15 minutes. Okay, so I add 15 minutes to the timer in my head. Right. So, fingers crossed, if I run this, well, first thing is hopefully it doesn't crash, but it did. Hopefully that crash was in the compiler, and it is. Well, that's interesting. That's really interesting. Why would it be? Let's have a look at what we're dealing with here. This code seems like totally unrelated to what we were doing. I wonder if we could... I don't know how we somehow broke that. But what is it? Left-hand side is an identifier. Examples playground module array 0. Okay, so $ array 0, so that's kind of like a, not an explicit array. So that's to do with this, I think. Huh, that's not actually even the thing we were testing. I think it was to do that because this doesn't have any array in it. Yeah. Okay, so we need to come back to that later, but let's first just check our assembly and see. Yeah, see, here's the exit. So this is much shorter now. Still has this stupid double allocation, and then at the end, this business here is to copy copies from one allocation to another. So that's also stupid and should get rid of. But this is the initialization that I wanted to check. So it's setting 2 bytes to 0 at the start. Then the third entry is getting to 42. And then from the fourth entry, we set another 2 entries to 0. Perfect. And if I put an empty one here, then we just set 5 bytes to 0. Perfect. So that was kind of the just a little optimization I wanted to do. It felt just a bit wasteful before, and it's not so hard to fix. Now, why is this array not working? Even though that happened in generation, I'm actually, because I haven't looked at this for a while, tempted to have a look at the type checking for compound literals. So this is where it's not assignments. So again, this is like this style compound literal. So for each child, so this is for each member of the compound literal, we check. I feel like this doesn't need to be done per child. We might switch that around a bit. Compound literal for type must contain a certain amount of elements, and for a slice, like we have here, yeah, this could be any size, so it doesn't need a certain amount of elements. So that's good. And then, yeah, for each member we type check and make sure that, you know, that the type of this matches this. Okay. Now we're coming down here. So this is the other kind of compound literal with assignments in it, like the struct. And for each member, if it's a slice, we check to see if it's raw or length. We make sure the member is... This seems a bit light. We do have a check to make sure it's a member. So if I was to do if equals 7, that should throw an error. Yeah, if is not a member. But that still doesn't look like enough to me. Like for a slice, first of all, you know, like up here, when we were doing the non-assignment style, this style, we were making sure that there was the right amount of members for the type. Down here, we don't do that. And we don't check for duplicates, it looks like. So for example, I could do C equals 7. Could I? Yeah. And it looks like the C equals 7 is just getting ignored. Okay. So I think we generally need to tidy this up a bit. Is there anything wrong with this? I don't think there's anything wrong with this. That error was like not legit, but I think we also need to tidy up our tap checking because it's not very good. So turns out there was a few things in here that we need to fix up. This for loop, I think I want to just like separate it out. So let's put that down here. And this is just going to be this is the else. So this is for the non-assignment type. And this part up here, if I cut out this part, is just for when it is the assignment type. So actually I'm going to take this and put it here like that. But that requires there to be child nodes. So let's just say if length child node length of this. So actually, yeah, so if that length, if there are any children, and the first child is an assignment, then we do this style stuff. Otherwise, we do this style stuff, these kind of checks. But I think even before we establish that, we want to do some checks. Let's at least take this part. Let's deal with this in isolation for now. So this is the type that's for arrays and slices. So if we've discovered that we're doing arrays and slices, then we make sure that that's what we're looking at, and we type check each of the members. I think that's fairly straightforward. So this allows slices and structs. This allows arrays and slices. So maybe even right from the get-go, I think what I'm going to do is like a linear search. I don't know if I can just do this, can I? Linear search, the array goes first, and then put type node.value. Missing type compound literal. So do I just have to go like this? But that's right, I haven't done Odin for a while, it goes like this. That seems happy, I think. So what I wanted to do is just do like an initial check to say like, hey, you've got to be an array or a slice or a struct. You've got to be one of those. Otherwise, there's no point in us continuing. And for an array, a slice, or a struct, I think it's always valid for it to just be empty. For all of those things, it can just be empty. But not a slice. Not a slice. I think it's a slice either needs to be like this, or it needs to be the other form could be raw equals, this is a bit hacky, but like a pointer to big structure A, because this is expecting a pointer to a U8, and A is a U8. So this is actually taking this struct and sort of converting it into a slice. Crazy. So yeah, it could either be like this form or this form, but a slice, well, I guess if a slice is like this, then it would just be an empty slice. I guess that is valid, actually. Okay, so any of them can be empty. So if not valid type, then let's throw an error. Yeah, those are more specific ones. Cannot use a compound literal of a certain type. So we just say just generally cannot use compound literal for type blah. Okay, so we've established that we're one of these. So if we look in and we see like, okay, we do have members. Maybe actually what I'm going to do is I'm just going to say, if there are no members, let's return. There's nothing more to do here. Return true. It's valid. So now we know there was so much type checking missing here. So now we know that we're talking about something that we can do a struct, a compound literal for, and we know it tells children. So what kind of children are there? If they're assignments, then we need to narrow it a bit further and say, look, it needs to be one of these. It needs to be an array or a slice, otherwise it's no good. And if it's an array, it needs to have a certain length of elements. We need to make sure the elements are okay. All right. Then we need an else. So now we're talking about where we are not. Now we're talking about this kind. Not this kind or this kind, but this kind. So now we're looking at each child and we're saying, okay, for a slice, it needs to be raw or length. And there needs to be two members. It has to be raw and length. You can't specify just raw or just length. So it needs to be two. That's that same kind of check that we did up here. So for arrays, oh no, sorry, we are looking at this style now. We're looking at this style. So arrays don't work here. It's only slices or structs. So this, yeah, so this here we should never get here. Unsupported unsupported compound literal I don't I'm just going to sound... Generally, I say unsupported something. I feel like this is not really what I'm talking about, but it's close enough. So for a struct, I don't think we need to validate the number of things that are in here. If we make sure that there can't be duplicates, and we make sure that each member matches, a member of the struct, like we can't put F in here, which we already do. And if we further restrict it so that you can't have two C's, then as a side effect, we are making sure that you don't put too much stuff in there, So I don't think we need to explicitly say like, hey, don't put too many things in here. For a slice, however, we need to make sure there are exactly two. So where was it? I think it's for the array. Must contain X elements. So we can go like this. Yeah, if it's not two, compound little for type must contain two elements. Okay. Great. I think that's that. So I've restricted so that for this case, we need to have two, raw and length. And now let's prevent duplicates. I think that's the one extra thing we need to do here. Yeah. So in this loop where we're going through the children, I guess we need to do like found member names, which is a dynamic array of strings. And each time when we come in here, so child LHS no dot value, that seems to be the name, the member name. Which we have here. So we need to do another linear search over the found member names, and we're looking for child LHS node dot value. Duplicate member found. I think we need to turn that into a slice. And if duplicate member found, we've got is not a member. So let's make that is a duplicate member. There we go. And then we need to actually append it to the list, so that next time we come through the loop, it's actually in here, so that we actually do find a duplicate. I think that should do it. C is a duplicate member, big struct has not been declared. Yeah, that's a bit weird that we get that error. Because we got an error in here, then the result is, because we quit out early from that statement, the result is that this never actually got declared, and then subsequent references to it fail. It's not terrible. Okay, so we can't have duplicates. We can't have members that are not part of this, and I think that's good enough. And each of these is type checked. Yellow should fail. Yeah, incompatible types. So I think that's pretty good for that one. This one, if I declare length twice, let's see what happens. So first of all, it's complaining because there should be just 2 things in here. So if I narrow that down to length and length, then it says length is a duplicate member. Great. What if I take that out and just have 1? And again, it says it needs to have 2 elements. So then I run that. We just have a duplicate thing. And this is where we had the error before. Yeah, this guy is not happy. Right? I think if we take this out, it's okay. So this should be valid. And what it does here is it basically creates an array. So maybe just to keep things totally minimal in the assembly, let's see what it's actually doing. But it doesn't get that far, does it? It actually crashes here, which is really weird. Feels really weird. So the LHS node, the value is... Right, so this here, in our example playground module, we have an identifier which is $array_0. And what that represents is this, which then gets assigned to this slice. So this, because a slice is just a pointer and a length, so it needs something to refer to. So we create this array object in the background, and then this slice is just referencing this implicit array kind of thing. So we do allocate something this big, and then we reference it. That's how it works. And what's going on here, where is it? Program, I think, is that this array does not have an allocator, and this procedure is expecting it to have one. Does it need to have one, is then my question. So it's basically trying to detect if it's a compute shader, and if so, generate it like a compute shader. Otherwise, do this, whatever this is, some alignment stuff, and looks like this is kind of like a nil initialization as well of the array. And so that's for all the static vars. Oh, and this gets populated along the way, and we do some more stuff with that later. Okay. And apparently we need that. Be nice if we didn't. Anyway, I think I understand now what's going on, and I don't think we need this allocator to be here. So I think we can just say like I think we can just add a null check, I think this is fine. Make sure that there is an allocator before we check the value of it. That might be what we did wrong here. Yeah, now it exits with 0. And if we have a look at it, so we have this is our implicit array that we created. If we go to the bottom, we can see here in the data section, we created something with this name, and this is define bytes. So it's saying define 3 bytes, basically, and set them to 0. So that's our array of 3 bytes, because a U8 is 1 byte, and we have 3 of them. And that's how we do our static variables. So initially it's 0, and this is our assignment. So the first thing it does is it assigns the values 1, 2, 3 to this array thing, and this here is creating our slice, basically. So it's saying the first part of the slice is our pointer. This is the pointer to that array, and this is the length of the array is 3. So that all looks legit to me. So we managed to fix that bug. We fixed a few bugs there, actually, I think. Yeah, I think we fixed a few bugs. We made the type checking much better for these compound literals. We optimized this kind of assignment compound literal, and we made that work, which wasn't working before. Nice. Not bad. And I think we are only about 40 minutes in. So I think we can go back to our list here. So this is our nullifier, which we fixed up. There was this here. Better parsing, type checking, more restrictive for compound literals. So it looks like I was thinking about doing some stuff in parsing even. I think the type checks are pretty good now. Like if we go to because the parsing is just for grammar, right? So if we go to this view, there we go. And we look at our compound literal. That's here. So this, so parsing, all parsing should do is make sure that we're conforming to the grammar. That's basically all it does. So I'm just trying to see whether it should be more restrictive or not. So I'm saying it's a simple assignment. So I think basically what we're saying is that it's curly brace and it's either comma separated simple assignment statements or comma separated expressions. So an expression, it could be, because it could be 1 plus 1. That's legit. So then the first element would be 2. So these are just expressions. They don't have to be just numbers. That should work, right? Yeah. Then if I do like os.exit my slice 0, I'm going to have to import OS for that to work. Then the exit code should be 2. Oh, sorry, my slice 2. Yeah, exit code 2. So that's fine. We're looking at the grammar. So I think the type checking of those is fine. The type checking of those is up here. So we just loop through them and type check them like an expression. And make sure they match the child type node, which is perfect. That's fine. Just want to remind myself what a simple assignment statement is. Identifier equals scope statement or right-hand side expression. And as long as that, so how do we type check that? So that's when we go down here for each member. Yeah, we do a bunch of validation checks, but then eventually we come here and we type check a right-hand side expression. So this is the left-hand side. Oh yeah, so we validate, that. So this is where the parsing should tell us that it's just an identifier. So let's go back to parsing. I just want to, because I've been away for a little while, I just want to make sure that I understand this properly. No, not compound literal, simple assignment. So it should, yeah, it tries to get an identifier, and if that fails, it says left-hand side of a simple assignment must be an identifier because we just fixed up those error messages. So that seems legit. That's like parsing is taking care of that, so we're just making sure that it's an identifier that we are expecting. and then we check the right-hand side to match the left-hand side type node. Okay, I think that seems legit. I don't know that the parsing needs to be more specific than that. I'm not 100% that I remember. I mean, I don't remember exactly what I meant by this, but we have made it more restrictive and made the type checking better. And I'm not sure what other checks we would need. So I think I'm going to leave that one, say that one's done. I think that's okay. Okay, so we've been 45 minutes. We've got another 15 minutes. So I'm just trying to think what's another one. That we can do that is easy. Prevent recursive struct. That would be a nice one, but I mean, can we do that one? How do we type check struct? I don't think we type check types, if that makes sense. We don't, like, types are basically valid because they match the grammar. And that's enough. Well, for an enum, we should have the same thing where we don't duplicate. Right? I don't know if parsing takes care of that. I don't think it does. Oh, I wonder if you could actually do that. If we go back to our playground and uncomment everything, we do have an enum in here somewhere. Here we go, foobar. So if I go foobar bar, does it fail? Duplicate bar member bar found in type. Okay. Duplicate member found in type. Okay, so this is type checking of a primary, and if that primary is a type, then only for enums we do some checks. Okay, so we could add a struct check in here. Else if node dot value equals struct. Oh, not else if. If. Yeah, no, else if. I mean, I guess we could do a nested switch, couldn't we? And we do like switches, so I feel like that's like the kind of consistent thing to do at this point. So now we're saying case enum and case struct. We don't need to have these brackets. Okay. So for a struct, how do we do this? We don't want, so maybe I should explain first what it is we're doing. Prevent recursive struct. So the problem is, let's make one in our playground. Recursive struct. It's a struct with a member, and that member is a recursive struct. I'm just trying to think now if that's actually even possible. It might complain already that it doesn't know what this is yet. because it's only once we've finished this statement that it's able to know what this is. And just so you know, like, the problem with this is, let's say, for example, we want to find out, like, anything that we declare, any variable needs to have a known size. We need to know how big it is so that we can allocate space for it, wherever we put it. But if we say, like, it has a U64 and this, but we can say, okay, this part here we know is 8 bytes. Great. And this part here is a recursive struct. And a recursive struct, we know that's 8 bytes. But then it also has a recursive struct. you know what I'm getting at? Like, you're just going to recursively, if you try to calculate the size of this, you're going to get a Stack Overflow, because you're going to just you'll never know how big it actually is. So you could have a pointer to a recursive struct. That should be okay. But you couldn't have it itself. And that's actually why we come across this problem in this project, actually. That's why in our node type, we can't have just a node. See, Odin doesn't allow it, probably for the same kind of reason. But we can have a pointer to a node, because a pointer to a node has a known size. A pointer is always 8 bytes, well, on a 64-bit system. So this should not be valid. I'm really curious to see what happens, actually. We probably need to... so yeah, it says recursive struct has not been declared. Recursive struct has not been declared. So the problem actually is not that we could have done this. We couldn't do this. The problem is that we can't do this when we should be able to, and that's a very different problem. Potentially more difficult than I had bargained for, considering we're kind of coming to the end of the video. Yeah, I think that one's going to take more thought about, how do we handle this kind of thing. We need to allow there to be... It's kind of a special case, I think, for us. I think a struct is the only place where this could really happen. I'm trying to think what else. I mean, you can have a recursive procedure that calls itself, but when you're type checking the contents of the procedure, the name of the procedure should be available, like should be known at that point. So I think a struct is the only thing I think that can be recursive like this. But I'm just not sure exactly how to go about that. So I'm going to undo these changes. What? And I don't think I'm going to fix that right now, but I'm just going to put it to do here. Like, we do need to do that. So actually in our do we still have the to do open? In our to do, it's more like allow struct member to be pointer to struct, but prevent recursive struct. Yeah, so that's a bit more complex. What else can we have a look at here? Better type checking for type alias link import. We also have some bugs. Assign empty compound literal. Properly restrict compound. I feel like we took care of that just now. That we should do, but I think maybe this one that I saw just down here, this, I think we can at least do some of this, because I do think that's a bit messy at the moment. So let's just close a bunch of these files that I don't think we need anymore. So especially like link, I feel like it's not handled it's handled in kind of a special way that I don't like. So I think we're type checking statements. And here it's, it's like, yeah, it's in this here is kind of like our pre-loop, which I don't like. This is our main type checking loop, and this is our pre-loop where we do like some extra special stuff, like we resolve as many types as we can, make sure the type information is right. We do our links, we do our imports, and I think that we can, and these are like procedure assignments, which we put in the special out of order identifiers. I think we can at least take the links out of here to reduce this. I think like link is just a procedure like any other. Well, not like any other. The special thing about link is that it doesn't get compiled. It's actually a hint to the compiler. It's like an instruction to the compiler. So where do we use link? I think it's in the standard lib, like GL. See, we say link GL. So these are all like definitions, and they're all like marked as extern, all these procedures. And this is some funky stuff that I do on top. But so there's all these procedures that are defined in the GL lib, right? And then we need to link that lib. So this is telling the compiler to link that lib. It doesn't produce any assembly, it just affects the linking stage. That's the special thing about it. But I don't like having this special thing here. I think it should be able to just get type checked normally, just like any other procedure. And it's just during generation that we do something different, really. I'm pretty sure. So if we do type checking of it's a call, actually. It's a procedure call. So it's not a type. So we should be just like type checking. Yeah, type checking procedure call is actually really complex. And it's because of generics, which I'm not a big fan of. But I think it should be fine, and I don't think we need to change anything there. I think it's really generation. Yeah, that makes actually a lot of sense to me, because it's really, like GLSL doesn't need to worry about it. It's x86, 64, or ARM. These kind of targets should worry about it. So I guess it's here, call. When we're generating a call, okay, so here we're getting the name. So we're checking if it's extern, parameters type return. And because it's all type checked correctly, I think we should just be able to say, like, if the name of the procedure is link, we also need to make sure that it's not a member of something. So the procedure node, I don't know if we ever check that in here. Maybe in the type checking. I feel like there must be something, because, okay, we've established that it's called link, but what if, you know, if we go back to our playground, what if, hypothetically, we made this struct called with link, and it has a member called link, which is a procedure. Then when you go to call with link.link, I mean, obviously you would need to actually you would actually assign something to it so that it's something you can actually call, and then call it. We don't want that to go into this special case, right? So I'm just trying to remember now. How we know that. So I'm pretty sure it's in the node somewhere. So the node has a data type. I'm pretty sure it's like, I'm pretty sure it would be a child of the node, of the procedure node. And again, if we go back to type checking of the call, the procedure node, which is the first child, this should just be an identifier right now. Or does it already have a type? I feel like it's just being used as a type, but I'm also not seeing anything referencing like the children. I thought it would get populated with children. I guess it would need to be is it this here? Get identifier node. It's been so long since I've done this. Yeah, this is like getting the declaration of it, but we don't actually use that. So we would have to do that again. And we also need to do that for the syscall. Because syscall doesn't, we have the same problem with syscall. You know, we have these checks like, is the procedure called syscall, but it could be a member of a struct. So maybe we need to say like, well, this is in type checking, isn't it? Where is this? Yeah, type checking. Get identifier node. And we're just passing in the, context, okay. So that would need to be type checking dot, which is probably not imported. And I don't like importing it in generation. I think I'm going to do something about that sooner or later. And this get identifier node returns the node, and then this is like the path to the node. We don't care about the path in this case. We care about the node itself. And it's the procedure node and the context, which is going to be a generation context, not a... So this is why I don't like... I think I have done this somewhere else. Yeah, and I said to do, this is hacky. Maybe I copied that actually. Where are we here? Along with the hacky note. So we make this TC context, and then we put the procedure node in. But there we needed the path. Here we need the node. And now I want to say if dot children equals 0. If it has a child, that child will be the struct that it is a member of. So it should not, or it could be, you know, like here, this procedure. This would be the child node. In this case, it's a module. But it could also be, you know, in this case, with A, the child of that would be the struct. Or no, with link, the child will be the struct. So if it's not part of a struct or a module or anything, it's just someone just called link on its own, then I want to do this link stuff. So I'm going to cut that out, put it in here, and it's probably all wrong. I don't see what's wrong with that. Or maybe it's just that we don't actually have a link. So the call, so we're looking at the parameters. Params type node. Now what's the actual parameters? There's so much in here now, it's quite messed up. Yeah, so node.children, so this expression node, this is the actual thing that we're feeding in. So in the case of here, you know, the string GL, that's what we want. And that's this. Yeah, so actually it's just, in this case, it's just called node. That's what it is. This node is the call node. The first child of it is the name of the thing getting called, and the rest of the children are the parameters. We need to import slice. And it's not a continue, we just go like this. Link it if we need to. And return. Do we need to return true or something to say that it was all good? Oh, we return a location. I think we can just return empty because the procedure doesn't return anything. I think that's it. So we find the link, we get the link, we check if it's already added to our program object, and if not, then we add it. And this, you know, program.links will get used in main. Yeah, when we go to link, this is our link command. We construct all of our -l links and we add them into the command. That's how it gets used. So that should work. I mean, I don't think the playground... Ooh, I don't think the playground has anything like that. Oh, it's because I put this slide in here. Let's take this stuff out. That was just an example. Duplicate member bar, that's right, I need to take that back out. Where is it? So that ran successfully. This is all of our test stuff. It looks like I remember it should look. But I think what we actually need to test is the OpenGL, which does not seem to run. And it's it's here that we have the trouble. Interesting. So procedure node is an identifier. The value is func. And the children, it has one child, which is task. See, it's like task off. So this is exactly the case where we have a struct whose member is func and it's getting called. So the child is task. Okay. So shouldn't it just fail that condition? I don't really see what the problem is here. Fault. That was procedure node I was looking at. So maybe identifier node was not found. Right, because it's not actually an identifier. If it's a member, then it's not itself considered an identifier. Task is like, it's not an identifier that is saved in a context somewhere or saved in a scope somewhere. You know, like bar is not a name that you can just refer to directly. See, we create a variable called bar even though this is here. So this is not like an identifier that we have to avoid conflicts with or anything. This is. So when we're talking about task.func, func is a member of a struct. We don't need to, you know, the func by itself is not stored anywhere. You know, we can't look for it because it's not stored anywhere. So actually by checking that, so if that is nil, that means that it is a member of something else, which is actually what we wanted to check. So I think the check is actually, if it's not nil, that means it's not a member of something else. It's its own standalone procedure, and it's called link. That's what we wanted to check. Wow. Undefined reference to glfw init. So I have a feeling that this is not worked. So if I do like format.println link, just to check that, you know, anything's getting printed out, I have a feeling, yeah, nothing's getting linked. So this has failed. So if we must find some links though, right? Let's just print out link whenever we find a procedure node whose value is link. It never happens. Are we specifically excluding link? Is link statement. So we're saying if it's a link statement, we don't go into generation. But we should, because now our generation is just adding it to link. Just adding to the links and then not doing anything else. That's considered our generation. And then it runs. Yeah, we can see link glfw, link gl, link glu. Perfect. So let's take out our debugging. That seems to work well. So that might seem like a weird little change that I just did. Like I just moved it from here to here. But to me, that feels like a more appropriate location for it. And like I say, I really want to try and reduce this. I feel like this is kind of special case stuff, and I don't like it. So let's see. Maybe later we can improve this whole thing. This here, I'm not a big fan of either how this works. I mean, it does work, but I'm just not a big fan of it. Okay, but I think that's pretty good. My timer is at an hour, so I guess we've done an hour 15. But I'm pretty happy with that. I feel like we've really improved our compound literals quite a bit. I mean, and this one was just broken. So we fixed that up. This one here, we still need to have a look at. I need to think about that a little bit offline, because to kind of think from scratch how to do something in a video is going to take a long time. Sometimes. Some of these things, they need a bit of thought put into them. So I don't want to do that right now. But yeah, I think I'm happy with that. So thanks for stopping by. Have a good one. Ciao for now.